A little introduction to Jetstack. Jetstack is a British Kubernetes company. We got quite famous around training and workshops with a lot of our customers, especially at the beginning of the Kubernetes era, like 4 or 5 years ago only. Since then, we've done a lot more. We do quite a lot of professional services for different kind of customers, ranging from creating really specialized pieces of work, like creating an etcd operator for customers, to like doing general platform work and getting our customers up and working with Kubernetes and everything around it in the cloud native space. After they've come to production, our customers sometimes require support, and for that we have like our subscription package, where we have like SLAs with like our support, where we do third-line support, but also where we have like an aligned CRE that will help our customers with making sure they don't have any outages, as well as doing quite a lot of proof of concepts in improving their developer experience or their platform. This also comes with Preflight, which is our compliancy checking tool. We also do quite a lot of open source development. We're quite known for creating Cert Manager, but besides that, we also have like kubectl proxy, version checker. We used to have Tarmac and kubelego as well. Talking about Cert Manager, we have Cert Manager Enterprise, which is like a 24. We launched this quite recently, a month ago, with the graduation of version 1.0 of Cert Manager, and we do 24/7 support on this. We do sign builds. We also give like visibility, any configuration issues you have with your certificates, with your ingresses, or like the Cert Manager itself. And you also get the necessary access to the best practices, blueprints, and playbooks around Cert Manager. At this moment, we're also full in development for some extra enterprise features, but these are still early in the work of progress. But if you're interested in having some support on Cert Manager, or you want to get certain features in, contact us. We're happy to help. The agenda of today is we have an introduction to Google Cloud Anthos by Henry, who is a Google engineer. And then we have hybrid scenarios with Google Cloud Anthos, which is done by Paul Jones, our solution engineer at Jetstack. I would say, enjoy yourself.
Great stuff. Thanks, Matthias. And let's do a quick sanity check first. So can everybody hear me? Great. So let me share my screen, and we'll jump into the content that we'll go through today. Okay, so I'm hoping you can all now at the moment see my title slide, which is an introduction to Google Cloud Anthos. Yes. To begin with, let me introduce myself. I'm Henry, as Matthias said. I'm the EMEA Solution Lead for Application Modernization at Google. And what that means is I work with our customers to help them modernize their applications. And typically that modernization work stream is focused around Kubernetes, Anthos, and the surrounding kind of technologies in the Anthos portfolio. So what I'd like to do today is to talk a bit about what Anthos is, give you some background to how we got to where we are. And second, I'd like to introduce the Anthos architecture and its components. And then I'd like to finish with a couple of customer stories. So to begin with, some background. As mentioned, Anthos is our platform for application modernization. Anthos is built from the ground up to enable enterprise-scale application modernization across a range of different platforms and environments. Now, one of the key aims is to provide a consistent and reliable platform for running modern applications, but catering for personas such as platform operators, service managers, and application developers. And as you can see, Anthos is capable of spanning on-prem, edge, and cloud environments, as well as other managed Kubernetes platforms. Now, to sum all this up in a single sentence, Anthos is a managed application platform for enterprises that want faster modernization and greater consistency in a hybrid and multi-cloud world. Now, I'd like to talk through this statement and kind of dissect some of the key words and phrases to highlight some of the Anthos capabilities. So Anthos can be consumed in a subscription-based or a pay-as-you-go model. Automation takes care of cluster lifecycle management, patching, and upgrades, which leaves you free to focus on your business needs and not the non-differentiating toil of cluster management. So one typical customer challenge with self-managed clusters is the pain of Kubernetes version upgrades, for example. Now, the automation built into Anthos means that this task can be removed from the operational workload. But Anthos is much more than just managed Kubernetes. Anthos is a full platform for application modernization built around open source technologies for service mesh, for security, for build and serverless application development patterns. As a core contributor to Kubernetes for container orchestration, Istio for service mesh, Knative for serverless, and Tekton for native Kubernetes build pipelines, open source has always been a major part of Google's DNA, and it's this open source software that's at the heart of Anthos. So while Kubernetes is part of the stack, it's just one of the building blocks, and we'll come back to how those building blocks fit together a little bit later on. So starting with our early design partners, Anthos has been designed for large organizations with complex needs. Role-based access control and enterprise identity platform integrations mean that secure user cluster interactions can be managed and audit trails can be maintained. Now, what exactly do we mean by modernization? Well, alongside the core Anthos platform for managing modern cloud-native applications, we're also aware that application modernization is a journey. So to help with rapidly moving more traditional applications to Kubernetes, we built Migrate for Anthos. Now, Migrate for Anthos includes tooling and automation for containerizing legacy application workloads that run on virtual machines, meaning you can choose which model fits your migration and modernization roadmap. Migrate for Anthos is able to package up VM-based workloads into containers that can then be run on Anthos GKE clusters. And next, by consistency, we mean relying on portable and declarative configuration and policy to make it easy to run across cloud and on-prem. Centrally defined policy and configuration can be automatically synchronized across the whole estate so that you can be confident you're always compliant. Moving to a multi-cluster model, it's really important to consider how you maintain consistency and avoid snowflake clusters with manual changes applied. And the automation baked into Anthos allows you to do just that. And again, we'll talk a little bit more about how that works later. And finally, as I mentioned, you're able to take advantage of portability, meaning that you can use, for example, the cloud for elasticity and scalability, while retaining particular components on premises for data gravity, latency, or regulatory reasons. And one common pattern is to begin modernizing an application on premises, then later move or re-architect it perhaps to a cluster running in the cloud once the application components have been decomposed or decoupled. And splitting application components across cloud and on-prem is one way to be able to get the best of both worlds. Thinking about a timeline, Anthos represents the culmination of more than a decade's work at Google. Since around the mid-2000s, almost all software we develop and run at Google has been containerized with orchestration and cluster management from our orchestration platform called Borg. Now, Borg and the kind of surrounding technologies gives us Google-scale application management capabilities, and we wanted to bring some of those patterns to the world outside of Google. Now, one of the main Linux kernel primitives called control groups, or C groups for short, that's used for what we know now as containerization, was open sourced by Google and made it into the Linux kernel back in around 2008. And the work to externalize some of the patterns used within Borg resulted in Kubernetes being unveiled and open source in 2014. About a year later, we made our managed Kubernetes product, Google Kubernetes Engine, or GKE, generally available. And in 2018, we announced GKE on-prem, which is the capability to run Google Kubernetes in customer data centers. Moving on from that, the following year, we announced Anthos, which incorporates a whole ecosystem of technologies focused on application modernization, built on top of Kubernetes. And since then, we've been working hard to bring Anthos to more environments and build new capabilities into the platform. So now that we have the background, let's look in a bit more detail at the Anthos architecture. Now, the high-level architecture diagram you can see now shows the main building blocks of Anthos. At the bottom here, you can see Kubernetes providing a consistent abstraction across on-prem, edge, and cloud execution environments. Now, policy and operations management is built into the stack, which maps onto the component names, as you can see. Let's start by jumping in to talk about Google Kubernetes engine, which kind of sits at the heart of Anthos. Now, the Anthos cluster management capability is a Google-managed Kubernetes-based container environment for deploying production-ready containerized applications. A key component of Anthos is the on-prem version of GKE, which lets customers take advantage of Kubernetes and cloud technology in their own data centers. They get a GKE experience with quick manage and simple installs, as well as cluster upgrades that have been validated by Google. A highly available control plane means that your clusters are operationally resilient and able to tolerate failures of hardware and underlying platform components. And along with Google Cloud Console, this gives you a single pane of glass for managing all your clusters across on-premises and cloud environments. So this is designed to work where you want, on-premises or in the cloud. Anthos gives you this unified management experience across Anthos and Kubernetes deployments. So it's not just your binaries that are portable, for example, it's also everything else. Your application configuration, your security policies, your monitoring and alerting, your deployment and rollback processes. So instead of training all your teams several times on several platforms, you train them only once. Now, moving up the stack a bit, I'd like to go on to talk about Anthos Service Mesh, or ASM for short. Now, in principle, a service mesh allows you to control and govern the interactions between your services. And building this into the stack means that it's transparent to your applications, which means that you can take advantage of fine-grained control of blue-green deployment, of canarying, traffic splitting, and circuit breaking, all without modifying application code. And because it's pushed down the stack, it means your application development teams are free to choose any languages or frameworks they like. And as well as this, built-in mutual TLS authentication means that all service interactions are secure and encrypted. Now, thinking about site reliability engineering, or SRE, which is something we hold very dear at Google, Anthos Service Mesh makes it easy to set and view what we call service level objectives for application services based on aggregated telemetry data. It lets you easily create alerts to warn if a service isn't performing as expected and view it all from a unified dashboard. For example, you can view metric charts for individual services and deeply analyze them with filtering and breakdowns, including by things like response code, by protocol, by destination pod, and traffic source. You also get detailed information about each service endpoint, so you can see how traffic is flowing between services and get to measure and improve overall application performance. All of these are ways that Google SREs monitor and tune all our global services. Now, building on top of what we've covered so far, Anthos also incorporates some developer-focused components to streamline app dev work and provide a serverless developer experience for devs building applications on Anthos. We call it Cloud Run for Anthos. You can think of Cloud Run for Anthos as a developer and operator platform for your Anthos cluster. It provides a simple serverless experience for your developers to make them more productive, while giving your ops team the flexibility to manage their own clusters. Developers can take advantage of the higher order primitives, while application and cluster operators can continue to leverage the underlying service mesh and container orchestration primitives for super fine-grained control. And Cloud Run enables you to modernize in a way that kind of fits your business and IT needs. You don't have to change everything to adopt Cloud Run. And in fact, many customers adopting Cloud Run for Anthos are building new microservices that extend existing applications, so you can modernize in place. It's easy to spin up a microservice that talks privately to your existing services, all in the same Anthos cluster. Cloud Run for Anthos even lets you leverage advanced hardware such as custom machine types, GPUs, TPUs, and high memory compute. So in short, Cloud Run for Anthos lets you combine the best of serverless and Kubernetes. And because Cloud Run is built on Knative and Kubernetes, both of which are open source, you don't have to worry about having to do costly re-architectures and migration projects. One of the challenges with what we now call serverless has been the proprietary nature of most providers' implementations. The open source Knative project provides serverless building blocks, such as serving and events, which means that your serverless apps can run in the same way, no matter where they're deployed. So if you decide in the future to move your workloads from on-prem and into the cloud, it's just a simple redeploy. The best part is your IT teams don't have to relearn a thing. Cloud Run supports the same workloads and offers the same consistent experience, no matter where it's running. Now, earlier I mentioned consistent policy and configuration management, and it's Anthos config management that provides this capability within Anthos. So Anthos config management, or ACM for short, is a multi-cluster configuration manager that helps you have consistent policies across your clusters, whether they're on-prem or in the cloud. It uses a central Git repository to manage access control policies, resource quotas, and Kubernetes namespaces. All clusters synchronize themselves automatically to this central repo. It's declarative and continuous, so once you declare a new desired state, Anthos config management continuously checks for changes that go against this state and applies the central content, remediating manual changes if so configured. And it's cluster location agnostic. It works in the same way in the cloud or wherever your clusters run. And because it uses native Kubernetes YAML, there's no rewriting of existing Kubernetes configs, which makes it really simple to adopt. Now, from an operations perspective, observability and telemetry features make it really easy to ensure you have all the right information to effectively manage your estate. Cloud Operations Management offers full observability for your code and applications. Logging, monitoring, and application performance management features mean that you're not flying blind. It helps you aggregate metrics, logs, and events from containers, apps, and services, giving developers and operators a really rich set of observable signals that speeds up root cause analysis and reduces mean time to resolution. Logs can be retained or exported to other platforms. Metrics can be dashboarded and used to fire off alerts. And application performance management features, such as tracing, allow you to drill down into application components that perhaps may not be performing optimally. Now, centralized control with Anthos is proving hugely beneficial to many of our customers, saving a significant amount of time and automating away complexity. And in fact, one of them said, and I quote here, "Imagine having to manually check each of 300 services every time there's a change." And I agree. Manual toil can be really tedious and really error prone. And one of the aims of Anthos is to make this kind of automation easy. So based on some of the kind of pillars and principles and technologies within Anthos, I'd now like to hand over to Paul from Jetstack, who will be going into more detail around some of the Anthos components I've introduced.
Awesome. Thank you, Henry. I'm going to present my screen. Can everyone see my slides?
Yes.
And hear me okay? Presume?
All good.
Excellent. Thanks very much, Henry. Hi, everyone. My name is Paul Jones. I'm a solutions engineer with Jetstack, working in the field team. And recently, we've seen a lot of clients wanting to sort of transition to a more hybrid strategy. So I want to talk today about some of those scenarios in which those decisions are being made, and then draw some common conclusions from some of those scenarios and correlate that with some of the Google Cloud Anthos ecosystem components. So to kick us off, I just want to run through some of these common scenarios that we're seeing when leveraging hybrid strategies. So first of all, we're seeing requirements around kind of cloud bursting. So this is accommodating temporary surges in demand and providing kind of ad hoc elasticity. Think scaling for Black Friday, that kind of thing. So scaling out and then auto scaling back in when that demand is satisfied. Also running cross-environment executions, so where we have dev and test environments in cloud and kind of production on-prem. We also want to invoke legacy dependencies, so maybe having a stateless application in the cloud, like a front end, and have a global presence, and then have a legacy backend on-prem. Also, you might have data sovereignty requirements. So you might want to keep data in a certain geographic location, like the EU, and have GDPR compliance. As well as that, there's invoking cloud services. So we might want to make use of either proprietary or managed services. So, machine learning platforms or managed databases like Cloud SQL, and offload that responsibility to cloud providers and leverage their, years of expertise running these systems and, have their SLAs in place, and consequently making it more sort of easy to operate and consume from our developer's perspective. And lastly, having a multi-site deployment. So we might want to extend our presence in a particular geographic location. So the cloud introduces an overhead, to manage all these different environments. So ideally, we'd have some standardized tooling and approaches for doing this. So what are the commonalities with these scenarios? And these are the points we're going to sort of drill into one by one and look at some Anthos features as well. So first of all, we've got write once, deploy anywhere. So this is really focusing on the business logic of our applications. So we're not having to worry about where the application will actually run. We might want to start on-prem and then move to the cloud when we're ready. Next, we want to accelerate developer velocity. So, providing tools and simplicity to streamline development and have no obstacles to iterate on business logic. Next, we want consistency across environments, and this is a big one if we want to replicate environments and keep them in sync and have them as similar as possible. So there are, fewer failure points and variables to worry about. Also, with interoperability with legacy workloads, we want to extend the cloud into the on-prem and enhance our experience. So we need to make sure there's compatibility with bespoke domain-specific workloads. When it comes to observability, we need a way to monitor both environments with a single tool. Have a single pane of glass, like Henry was saying, and see the entire picture, and maybe observe kind of cascading failures across different systems. Also, we want to increase workload mobility. So we want to move workloads on demand based on business decisions. And lastly, avoid vendor lock-in. So we don't want to be tied in. We want to be kind of technically agnostic and maintain flexibility. So I just want to emphasize quickly the kind of Google Cloud value proposition before looking at specific areas of the ecosystem. So firstly, Anthos seeks to manage applications anywhere. So this is orientated around providing a consistent platform for all application deployments, whether that's on-prem or in cloud environments, and with legacy applications or cloud-native experiences. Also, Anthos facilitates users to deliver software faster. So this is addressing how business value can be delivered to stakeholders and provide, faster feedback loops, and empowering enterprises to create, software development lifecycles with cloud-native tooling, sort of agnostic of operating environment. And lastly, Anthos provides a holistic perspective to application and supply chain security. So as enterprise ownership sprawls across domains and environment and infrastructure, consistency, ease of use, and centralized control is pivotal to ensuring conformance across disparate and decentralized clusters. So Anthos is designed to kind of enable clients to modernize and avoid vendor lock-in to a particular platform. So firstly, with our first scenario, we look at the principle of writing once and deploying anywhere, and how this is a core facilitator to abstract away infrastructure concerns and focus on implementing and delivering business logic. So we've touched on it, Henry touched on it earlier with kind of Anthos GKE, but this is all about bringing the GKE experience to wherever we're running our applications. So with Anthos GKE, it's a turnkey production-grade conformant Kubernetes version with the best practice configuration already preloaded. So it's really providing an easy upgrade path to the latest Kubernetes releases and having which has been validated with Google. So as Henry's already shown, in Google Anthos, we have the Google Cloud Console, which is our single view of maintaining clusters on-prem and cloud deployments of GKE. So Anthos provides a unified management experience across Anthos and Kubernetes deployments. So to dive a bit deeper, let's take a look at GKE on-prem and specifically how it can help us with platform consistency and application ubiquity. So GKE on-prem sits at the kind of heart of Anthos and is a single deployment model that enables the availability of Anthos capabilities in an on-prem environment. So with GK on-prem, all components are hosted on the customer's on-prem virtualization platform. So with Kubernetes installed and running, we have access to a common orchestration layer. So this handles things like application deployments, configuration, upgrades, and scaling. So this helps deliver a consistent developer experience where we only have to be familiar with Kubernetes to deploy and interact with applications. So through Anthos CLIs, they provide kind of the interaction with vSphere to deploy an admin workstation, which is used to create and interact with an admin cluster. Then we have a bit of kubeception, where the admin cluster actually hosts the control plane for the downstream user clusters, and cluster lifecycling is managed through cluster API resources using the VMware provider for that to provision machines which form nodes of the user cluster. So GK on-prem also integrates with external storage systems through vSphere Kubernetes volume plugins to dynamically provision VMDKs, as well as integrating with F5 load balancers and bundled CSOR load balancers. So this workflow abstracts away infrastructure provisioning and maintenance and really provides a consistent tool for lifecycle management for cluster creation and maintenance whilst on-prem. And what this is really delivering here is kind of Kubernetes as a common denominator. So when it comes to writing once and deploying anywhere, we're now achieving environmental parity and enabling our services to run in the same way with the same configuration and workflow, but outside of cloud environments. So next we'll take a look at vendor lock-in, and ideally, we wouldn't be tied into a particular technology, but be able to embrace kind of the agnosticism we see in much of open source and the cloud native landscape, and have the freedom to choose the best tools for the job. So with Anthos, GK can be brought to other cloud providers like AWS to facilitate compatibility with existing infrastructure deployments and investments in managed services. So with GK on AWS, this follows kind of the GK on-prem as being an enabler to bring the GK experience to our infrastructure. So this means we can integrate with existing AWS environments and leverage Anthos, the Anthos stack to provide consistency across our clusters and workloads, whilst having centralized operations within the GCP console. So the solution for GK on AWS provides the requisite tooling for deploying GK onto our AWS environments, creating new or working alongside existing resources. So the design philosophy is kind of similar to the GK on-prem architecture, where we have kind of hierarchical models comprising of management and user clusters, with an AWS controller, which is used to create and manage the lifecycle of clusters on EC2 instances. So through Amazon CLIs, Anthos CLI, sorry, and Terraform, we can deploy a management cluster in AWS, which is hosted on EC2 instances within an ASG, and node agents, which bootstrap these instances to form the cluster. So once the management cluster is provisioned, we can create downstream user clusters using custom resource definitions. So these allow us to declaratively define our AWS cluster and manage the lifecycle of the cluster through Kubernetes resources. So a AWS controller subsequently makes requests to the AWS APIs to provision the AWS resources for these user clusters. So we then kind of have ALBs and NLBs and EBS volumes for state. And the user clusters is ultimately our GK cluster where we run our workloads. And kind of these instances are provisioned within an ASG to provide auto-scaling and resiliency. So once provisioned, these clusters are registered with the GKE hub in GCP, and the GCP console can then be used to interact with Kubernetes workloads in our user clusters. So we've actually got a blog post on this if you'd like to see more, and this covers the deployment and lifecycling of GK clusters on AWS. It's worth noting there's a kind of equivalent support coming for Azure even, which is coming soon. So this is fine for creating and managing GKE clusters, but what about managed clusters outside of GCP? And this is where Anthos attached clusters broadens our capabilities for bringing clusters into the Anthos ecosystem. So through attached clusters, we can have existing EKS and AKS deployments, which can be registered and added to the quorum of clusters in the Anthos ecosystem. So therefore, there's no refactoring to the cluster lifecycle or toolsets needed to change to bring Anthos to manage cluster deployments. So deploying a connect agent and registering the cluster via gcloud CLI commands allow users to benefit from being in the GKE hub for centralized management, even though the clusters are being managed by other providers. So consequently, we can use the same tools within GCP, like cloud monitoring and logging, to observe and inspect our workloads now across on-prem and multi-cloud deployments. This allows us to embrace our existing infrastructure investments in other clouds, as well as choosing the right tools for the job and for our customers and business cases. Again, we've got a blog post on this, which I'd encourage you to check out if this is of interest. So there we look at EKS and AKS attached clusters, as well as more experimental approaches using cluster API clusters, as well as kind. So a little bit more about that connect agent that runs in the cluster. So to connect a remote cluster to the GK hub, a connect agent is installed via a gcloud command, which deploys a GK connect workload to the to a namespace in the remote cluster. So the GK connect agent is running within the remote cluster, which calls back to Google over a long-lived encrypted outbound gRPC connection, providing connectivity between the Google Cloud Hub and the cluster. So this acts as the main conduit between the cluster and to serve our cluster and application state to Google Cloud, but also provides the connectivity to manage and deploy resources and configuration. So this extends our control for managing potentially all Kubernetes deployments in one consolidated place. So moving on. With kind of workload mobility, this can be a key differentiator to responding to market demands and providing flexibility to leverage the advantages of our platforms. As we've seen, Kubernetes is kind of an ideal foundation for hybrid cloud strategies, as it provides consistency, no matter if it's deployed on-prem or in public cloud. So this ensures kind of portability, interoperability, and platform agnosticism, whilst it extends the core functionalities. Because of this consistent platform, we can choose where to deploy our applications based on business decisions. So leveraging several environments can be critical to meeting technical and business needs. So this enables us to provide low latency services, bring services closer to our customers, as well as providing resilience against outages. We can move services to cloud to fulfill temporary surges in demand and scale elastically to satisfy a certain spike in traffic, and then auto-scale services back when that demand is satisfied. Alternatively, we can mitigate failure scenarios, so we can host failover instances of critical infrastructure and services. We can run blue-green deployments of applications across environments, and also kind of mirror traffic to our dev and test environments. So placement of services can then be based on what makes most economic sense in a particular situation. And also, developers can choose where to host workloads based on, to maximize their set of managed services. So, for example, we can leverage, BigQuery or Cloud AI in GCP or other managed services in other cloud providers. This opens up the possibilities of how systems can be architected, allowing for powerful compositions where previously it was complex to implement and had low cohesiveness. And this ultimately facilitates teams to deliver maximum value with the best tools for the job. So when it comes to Anthos, we can build on examples for running GKE on multiple environments and different cloud providers. And we can empower developers to move services depending on their needs. So we can, store data in GCS and have, a data flow ETL pipeline feedback results to on-prem workloads, or we can have hybrid connectivity to leverage preemptible instances in GCP to run workloads, or CI/CD processes to reduce costs and send results to on-prem storage. With consistency in our platforms and co-location of our compute and workloads, we can be able to modernize our applications in place. So firstly, with data gravity, our data is likely stored somewhere for compliance and security or processing reasons, and it can be costly and time-consuming to move this data. So services need to work in conjunction with data locality. So as we've shown with Anthos GKE, we can bring services closer to this data. So for example, we can leverage Anthos Hybrid AI, which is designed to let us use Google Cloud AI technologies wherever our workloads reside. By bringing AI on-prem, we can run workloads near our data while simplifying the development process. With legacy services, which are probably residing on-prem, such as mainframes and databases or other services that can't be moved easily to cloud. But we'd like to adopt modern development and operating practices and use the same tooling in cloud as on-prem. So again, we want to turn to Kubernetes to sort of do exactly this. Now we can modernize our applications at our own pace and move to cloud when it makes most sense. Through co-locating our Kubernetes clusters and legacy workloads, as well as using modernization tools like Migrate for Anthos, customers are able to modernize in place and transition to the cloud when they're ready. So next, let's take a look at developer velocity and how Anthos and software components can help us deliver value quicker. So with GK deployed, how can we yield that value and make it accessible and useful for users? So now we're moving up the stack and moving from the kind of infrastructure layer and the platform of Kubernetes to Cloud Run and Knative, which provides primitives for users to leverage the value of Kubernetes in their environment. So Cloud Run is based on Knative, which provides Kubernetes-based building blocks for serverless workloads. This builds upon the extensibility of Kubernetes and Istio and is a set of hybrid multi-cloud middleware primitives aimed at deploying, serving, and event handling. So this is orientated around abstracting away the complexity of the underlying infrastructure and making it easier to start building apps on the platforms. So fundamentally, this is providing serverless anywhere. Therefore, we can deploy serverless apps across the Anthos GK clusters, accelerating the delivery of business value and faster feedback loops. So this can be thought of as orientated around kind of serverless HTTP containers, with common use cases being web APIs, webhooks, lightweight data processing, sort of data DevOps automation, web applications, and mobile backends. So via Anthos, developers can now have a low barrier to entry to run services on GKE, bringing a serverless architecture to on-prem environments, enhancing velocity due to easier adoption, maintenance, software delivery lifecycles, and feedback loops. Now with our applications running across multiple environments and disparate locations with a mix of underlying infrastructure, how do we ensure that there is a workload configuration parity as well as conformance? So we need management and synchronization of heterogeneous hybrid environments, and this is a core tenet of Anthos. So when we're starting out, it's pretty straightforward. We kind of have a cluster per team, operating with sort of minimum namespaces and workloads. But soon we sort of scale out. We kind of outgrow that one cluster, and we need more environments for teams. We need things like redundancy and staging environments and multi-region deployments and things like that. Next, we have more tenants in these clusters and more namespaces. So quickly, we kind of have exponential growth in the number of applications and policies. So on top of that, we might have deployments across different clouds, different environments, and we need to maintain consistency and compliance across geographically distributed environments. In many deployments, we often see kind of use of imperative operations, but that's kind of an anti-pattern when it comes to Kubernetes, as we should be using declarative state. So how can we take this approach and transition from imperative to declarative? Well, first we start with a Git repo. We store all of our deployment in there, all of our namespaces, our deployments, our services, that kind of thing. And we declare the state of the cluster and the workloads. And then we can start thinking about Git as the source of truth of the cluster. And this is where Anthos config management comes in. So this allows Anthos admins to manage a consistent multi-cluster hybrid environment, which is entirely reproducible, auditable, and in a centralized way. So this shifts focus to a source of truth and a sort of GitOps methodology. So Anthos config management is a cluster controller which reconciles observed state with the desired state in Git. With Git as a single source of truth, any lower level modification in the cluster is overridden. The Anthos configuration management operator is deployed in the cluster in its own namespace and pulls information from this Git repo, which can be hosted in either on-prem or cloud environments. At this point, we can start doing PRs for changes to cluster workloads, and these can be checked for conformance before being applied to the cluster. And also we can roll back changes to the repo and reset the cluster or workload states. With Anthos and config management, the overhead to maintaining multiple clusters is consolidated into a pull-based model, which can be used to introduce hierarchical models of how clusters and applications are configured, audited, and governed. And lastly, with cluster sprawl from all of these deployments and applications potentially running in multiple locations across different environments, how do we monitor and track the health and performance of our services? So, as we've seen, the Anthos UI in Google Cloud Console is our single pane of glass for all of our Anthos GKE clusters, as well as our service meshes and configs and policies. So whether it's GKE on-prem or AWS or attached clusters, all of these clusters show up alongside our existing GKE clusters in GCP. So via the single pane of glass, we can manage and monitor workloads in the same way, no matter where they are. And a pivotal component of this is the Anthos service mesh. So very briefly, a service mesh can be thought of as a dedicated infrastructure layer that consolidates cross-cutting concerns of applications and infrastructure by controlling service-to-service communication over a network. So a service mesh provides a transparent and language-independent way to flexibly and easily automate application network functions. So this is providing kind of a separation of concerns between the application stack and the network stack. And Istio is the service mesh implementation for Anthos service mesh, and it's orientated around 3 pillars. So we've got observability, operational agility, and policy-based, policy-driven security. So focusing on observability, since all the communications goes through the mesh and the sidecar proxies in the service, telemetry can be generated by enriching the traffic flow between these services. So Istio, and by extension Anthos service mesh, can help gather latency, traffic, and error metrics in a uniform way. So we can build a service dependency graph based on routing and service calls, and allow us to sort of identify bottlenecks and single points of failure. Also, we can monitor services health and have SLOs, and we can define thresholds for each service. And from that have error budgets, which let us track how many failed SLI measurements we can tolerate. On top of that, we can have, we can then monitor sort of customer impacting behavior, and this will help with operations with event triggers and alerting for critical workload performance. So this telemetry data gathered by the service mesh works in conjunction with the services on the cluster, and the Anthos UI can help traverse these insights and gain a holistic view of our services and behaviors. So firstly, we can obtain metrics for each service, and this makes it easier to debug, and therefore we can sort of benchmark services. Like I say, we can then build a map of dependencies within the architecture. We can generate topology views and sort of see how blue-green deployments roll out, and also kind of weighted traffic distribution between versions. And then we can use the telemetry data based on the golden signals to define the overall health of the system. So with SLOs, you can have a concise and low noise signal, which gives you an overall health of your services. So with the Anthos service mesh, this can be deployed to Anthos GKE managed and attached clusters. And this is really making kind of the GKE hub the epicenter for application orchestration. So having stepped through all of our hybrid scenarios and the wish list items and the corresponding Anthos components, we can see how this presents a unique value proposition for managing hybrid and multi-cloud systems. So at the core is the infrastructure agnosticism and extensibility provided by Kubernetes. So this is leveraging Anthos GKE across GCP and on-prem, embracing existing infrastructure investments, and unlocking new possibilities for hybrid and multi-cloud compositions. This also allows for companies to modernize in place and continue to run workloads on-prem or existing infrastructure, but adopting Kubernetes and cloud-native principles. Then we can also extend our managed clusters beyond GCP into the other cloud providers via AWS and Azure, and also with attached clusters using EKS and AKS. We also saw with ACM how we can enable sort of environmental consistency. And also with Cloud Run and Knative, we can increase developer velocity and leverage serverless experiences across these platforms. And lastly, with ASM and centralized logging monitoring, we get a comprehensive perspective of activity and granularity of service-to-service communication, aggregated and viewable in one centralized location across all our clusters. So to wrap up, Kubernetes provides the common primitives and extensibility to run applications anywhere, enabling hybrid systems to be ubiquitous. We've seen with Google Anthos, this facilitates multi-cloud, multi-cluster management using ACM for environmental consistency and ASM for observability, consequently reducing the cognitive overhead and context switching, which is sort of required with maintaining multiple systems and sets of tools. So with feature parity across environments, business strategy can be at the heart of decision-making and dictate workload scheduling, placement, and scaling in line with digital transformation strategies. So with the suite of Google Anthos components, we have a single ubiquitous platform for infrastructure and application management, and this can orchestrate hybrid and multi-cloud deployments, which transcend location and domain. Awesome. Thank you very much. I think now I'm going to hand over to Matthias for Q&A.
Yes, everybody, if you have any questions, don't hesitate to put them in the chat. At this moment, there hasn't been any questions yet. So like now we have like still around 10 minutes remaining that we can answer some of your questions. Yeah, maybe like an initial question from my side is, and to both Henry and Paul, is like, let's say I'm a customer, I'm running at this moment in the data center, and I want to move to hybrid cloud to scale out with Anthos. Where would you suggest me to start? And then maybe let's start with Henry answering this as a potential customer. Where would you suggest me to start and how to tackle like going to hybrid cloud with Anthos?
Great question. So I guess I can riff off some of the patterns I've seen at our customers. I find that the customers that have had the greatest success are those that have chosen an application that isn't, initially probably mission or business critical, but again, on the flip side, isn't a toy or fake Hello World application. Generally, I encourage customers who are, making changes to the way their applications are composed and comprised to pick something that's real, that has use, and to run a pilot project to take that application, re-platform it, possibly even at the same time re-architect it, and demonstrate the value to the rest of the business. You can show a stakeholder early that, hey, this is a platform that can really be transformative for our business, the way we work, the way we run our software, and then use the experiences from that as a springboard to start to reflect broader changes across the organization. Now, I did some work recently with a customer, and who will, because it's under NDA, of course, will remain nameless. They chose to pick an application that was actually externally facing, which was quite a bold move, we felt, but one that they used to hold themselves to a high standard, and it ensured that their modernization of their first application platform was not simply a sort of internal experimental tool, but one that was actually generating them revenue from the way that their customers interacted with it. So while I don't necessarily believe that that's the model that should be applied to all organizations, adopting Anthos for kind of starting to adopt a hybrid platform, certainly picking something that's real, I think is a good place to start, and incentivizes teams and the broader organization to treat it as something real and not a plaything, as it were. Paul, anything to add to that?
Yeah, I think that's a really great answer. I think, demonstrating the value of, moving things and leveraging kind of what the main core tenets of cloud is, kind of like having that elasticity, and then kind of demonstrating that value, but then sort of having a candidate application like we see with a lot of customers. It's all well and good sort of, standing up infrastructure and things, but actually like generating the value and making, developers' lives easier, having quicker feedback loops and software delivery lifecycles, which are more sort of agile and things like that. I think, kind of demonstrating that value to the business is definitely a good starting place.
Cool. Thank you very much, both Henry and Paul. Like, maybe another question I have for you guys is, what's the most exciting thing of all the components out of Anthos that are now out there for you and to work with and to experiment with?
Jolly good question. I've seen, again, using our customers as an example, then I'll come back to my own personal opinion, that some of the biggest kind of organizational and operational benefits I've seen have come from Anthos config management, which is interesting because sometimes Anthos config management isn't the most like exciting or rock and roll component of the Anthos portfolio, right? You know, ensuring consistency perhaps isn't the most sort of rock and roll or exciting principle to apply. But I mean, once you see that way of working make operations teams' lives so much easier and remove so much of the pain that they previously had, that is something that is exciting to see. Flip side, I suppose, the component that I think excites the most people is probably Anthos Service Mesh. Seeing the way that you can, you know, generate a topology graph of one's services has got a lot of sort of wow factor, and I think is certainly pretty cool. For me, the components of Anthos Service Mesh that are most exciting, other than the sort of WYSI visualizations, are the ability to use the service mesh technologies to actually experiment and improve how reliable applications are. So one example might be, if I have an application that's distributed, I can use a service mesh to like deliberately inject faults into the communications between my services and understand better how my application will degrade. You know, if let's say 10% of requests across a particular network segment start to fail. And conversely to that, I can then start to use technologies built into the service mesh like circuit breaking to allow my application to gracefully degrade. And that way I have, you know, learnings from the service mesh adoption feeding into how I actually make my application more reliable, again, using those kind of service mesh technologies. So for me, I think ASM is pretty cool.
Thanks. And you, Paul?
I think two things spring to mind. So something I'd like to spend a bit more time with is migrate for Anthos. I think the concept of kind of taking a legacy workload and containerizing it and introducing it to Kubernetes and you know, whether that's kind of decomposing something into smaller chunks or just you know, bringing it into Kubernetes fundamentally and having some scalability around it, or having, you know, external config or things like that. I think that pipeline is kind of exciting. On the flip side, so it's a plug our own blog, but the attached clusters I found really interesting. Like we talked about, the concept of having EKS and AKS clusters viewable and registered with the GKE hub. I think that's a really powerful thing of like centralizing all of your clusters across different environments and seeing them in like one consolidated place. In the blog, we also kind of looked at cluster API and kind, and I know that that's not supported necessarily, but just the premise of that and how that can be expanded in the future, I think is really interesting, and yeah, just see where that goes and what can sort of come off the back of that. I mean, once you've got registration in GKE Hub, you can see all of your workloads and all the telemetry and things like that. So yeah, again, having that single pane of glass is pretty cool. Yeah,
and to pick into that, for me, like one of the most exciting features, it's not there yet, but it's coming, is Anthos on bare metal. At this moment, like if you want to start running it on premise, you still need VMware and you need to have like the full license. And then I know like most companies, especially enterprises, have some VMware, but sometimes you really want to use the brute force power of bare metal machines, but also just to make it easier to, for example, have like your GPU workloads working and those kind of things. And for that, like bare metal is like fantastic. You can go way bigger clusters, get way better optimal use of your clusters as well. And also, I really respect that Google is trying to solve this problem, because like you even have less control over the environment than you have on VMware. So it's a really hard engineering problem. And because I know it's a really hard engineering problem, it's like I have really a lot of respect that Google is trying to solve this with Anthos on bare metal, and I'm really looking forward to it. And it also allows you to kind of start moving with Anthos to the edge and run Kubernetes at the edge, kind of, and then way closer to your customers as well, which like really gets you closer to the customer, get you way more power out of Kubernetes, and lets you do more complicated stuff with Anthos, and really proves a lot more value as well for you as well as your customers. I see nobody really asked any questions anymore. It's now 58, so we're going to close off this webinar. We will be back in the next few weeks with more blog posts, more news about Anthos. We're also working on customer engagement with Anthos, so we will have probably some nice things to tell about Anthos, and we really want to keep you posted and share our knowledge around it with everybody. Thanks everyone for attending this one, and see you next time.